The boneyard of military aviation is filled with ambitious prototypes that never reached production, cautionary tales of technological overreach. The Shenyang J-11D, with only 2 examples built before vanishing from public view, seems a perfect fit for this category. But to label it a failure is to fundamentally misunderstand its purpose. The J-11D was not a failed aircraft, it was a brilliantly successful technology demonstrator. Its mission was not to fill squadrons, but to serve as a high-stakes crucible for the advanced systems, the AESA radar, the composite airframe, the next-generation avionics, that would be harvested and transfused into China's modern air fleet. Its cancellation was not an admission of defeat, but the final step in a targeted technology raid, a strategic success disguised as a production failure. The story of the J-11D is inextricably linked to the complex and often contentious lineage of the Sino flanker, a saga that began in the early 1990s. Following the Tiananmen Square incident and the subsequent Western arms embargo, a strategically isolated China turned to a financially struggling post-Soviet Russia for advanced military technology. The centerpiece of this new relationship was the Sukhoi Su-27Sk Flanker, a large, powerful, and exceptionally agile air superiority fighter that was a direct counterpart to the American F-15 Eagle. China became the Su-27's first export customer, acquiring dozens of the jets, and in 1995, signing a landmark $2.5 billion agreement to license-assemble 200 more from Russian-supplied kits at the Shenyang Aircraft Corporation, SAC. These Chinese-assembled aircraft were designated the J-11. In their initial form, they were flankers in all but name, constructed from Russian components and equipped with Russian NIIP N-OSO-1 radars, Lyulka AL-31F engines, and avionics suites. For People's Liberation Army Air Force, PLAHF pilots, the transition was jarring. The cockpit was a relic of a different design philosophy, a Soviet clock shop of analog gauges and dials that stood in stark contrast to the increasingly digitized interfaces of Western aircraft. This initial phase of cooperation, however, was a masterclass in technology absorption for Chinese engineers who meticulously assimilated the intricacies of the Su-27's formidable design. The arrangement began to fracture in 2004. After assembling approximately 100 of the 200 contracted aircraft, China unilaterally canceled the remainder of the deal, officially claiming the Su-27's capabilities no longer met the PLAF's evolving requirements. The PLAF sought a true multi-role platform with precision-guided munition capabilities, something the baseline Su-27Sk was not designed for. This official explanation, however, masked a more audacious ambition. 3 years later, in 2007, the world was introduced to the J-11B. Externally, the aircraft was a near-perfect replica of the Su-27, but internally, it was a declaration of independence. Shenyang had systematically replaced nearly every key Russian component with a domestically produced equivalent. The Russian radar was supplanted by the Chinese Type 1493 pulse Doppler system. Russian air-to-air missiles like the R-27 and R-77 were replaced with the indigenous PL-8 and PL-12, and most contentiously, a concerted effort was underway to replace the reliable AL-31F engine with the new, unproven Shenyang WS-10A Taihang turbofan. This move, which Russia viewed as a flagrant act of reverse engineering and intellectual property theft, caused a deep chill in military technical relations and led to formal investigations by Rosoboronexport. Yet this painful and diplomatically costly process was a strategic necessity for China. It was a forced evolution, a deliberate severing of the technological umbilical cord to Moscow. The J-11B program compelled the Chinese defense industry to create a complete ecosystem of advanced subsystems, radars, engines, missiles, electronic warfare suites, and the software to integrate them that it had previously been forced to import. The initial results of this crash course in systems integration were, predictably, fraught with difficulty, but this brutal education was the essential foundation upon which China's modern aerospace industry was built. The J-11D prototype, serial number D1101, first took to the skies on April 29, 2015, representing the apotheosis of this evolutionary journey. While retaining the iconic flanker silhouette with a length of 21.9 meters, a wingspan of 14.7 meters, and a height of approximately 5.9 meters. Its construction marked a profound departure from its predecessors. The most significant structural advancement was the extensive use of composite materials, particularly in the wings, vertical stabilizers, and engine air intakes. This strategic shift in material science served a threefold purpose. It reduced the aircraft's overall weight, thereby improving its thrust-to-weight ratio and kinematic performance. It increased the airframe's structural integrity and service life, and it contributed to a reduction in the aircraft's overall radar cross-section, RCS. This inherent stealthiness was further augmented by the application of radar-absorbent materials, RAM, and specialized coatings, creating what was described as a pseudo-stealthy airframe designed to degrade the performance of enemy sensors. Several subtle but critical aerodynamic refinements were also evident. The most visually distinctive was the new light gray radome, which was canted slightly upwards. Another key change was the relocation of the infrared search and track IRST sensor from its traditional centerline position to the starboard side of the windshield. This was done to accommodate a retractable in-flight refueling IFR probe on the port side, an engineering solution borrowed directly from the J-15 carrier-borne fighter program, which promised to dramatically extend the J-11D's range and patrol endurance. These modifications highlight a fascinating divergence in design philosophy from its Russian contemporary, the Su-35. While both aircraft started from the same Su-27 blueprint, their modernization paths diverged based on their respective industrial strengths. Russia pursued performance gains through brute force engineering, leveraging its mature expertise in aerodynamics and propulsion to create the Su-35, a heavier but super maneuverable machine powered by formidable engines with thrust vectoring nozzles. Shenyang, by contrast, pursued a more finesse-based approach with the J-11D, seeking enhanced performance not through raw power alone, but through the sophisticated application of advanced materials, weight reduction, and signature management. It was a design philosophy that showed a clear convergence with Western principles, prioritizing a holistic balance of kinematics, sensors, and low observability. The J-11D was not just a better J-11B, it was a fundamentally different answer to the question of how to perfect a fourth-generation airframe. At the heart of any fighter aircraft lies its power plant, and for the Sino flanker family, the engine has been the source of both its greatest challenges and its ultimate triumph. The story of the Shenyang WS-10 Taihang engine is a microcosm of China's struggle for technological sovereignty. The project began in the 1980s as an ambitious effort to develop a domestic high-performance turbofan comparable to the Russian Saturn AL-31F, the engine that powered the imported Su-27s. The development process was arduous, and the initial introduction of the WS-10A variant on the J-11B fleet was nothing short of a debacle. Early production models were plagued by catastrophic reliability issues. In a moment that calls for a touch of dry humor, reports circulated that the engines required a complete overhaul after a mere 30 hours of flight time, compared to the 400-hour interval for the rugged Russian AL-31Fs they were meant to replace. One can only imagine the pre-flight rituals required to coax such a machine into the air. The problem became so severe that entire PLAF regiments of newly delivered J-11Bs had to be grounded and ignominiously retrofitted with imported Russian engines, a significant setback and a stark reminder of the immense difficulty of mastering advanced jet engine technology. However, through a relentless process of iteration, failure, and refinement, Shenyang's engineers eventually overcame the substandard manufacturing and quality control issues. By the end of the 2000s, the WS-10A had finally matured into a reliable and powerful engine, capable of powering not just the J-11B, but also the J-16 strike fighter and even early models of the J-20 stealth fighter. The J-11D was designed to be powered by an even more advanced version of this engine, likely the WS-10B or a later production block of the WS-10A. This improved power plant was expected to deliver thrust in the range of 138 kN to 144 kN with afterburner, and featured a sophisticated full-authority digital engine control FADEC system for optimized performance. While some observers speculated that the J-11D might incorporate three-dimensional thrust vectoring to match the Su-35's super maneuverability, there is no photographic or official evidence that this technology was ever fitted to the two known prototypes. The saga of the WS-10 underscores a fundamental truth of military-industrial development. The high-performance turbofan engine was the ultimate pacing item for China's strategic autonomy. While airframes, radars, and missiles could be reverse-engineered or developed with relative speed, mastering the complex metallurgy, thermodynamics, and manufacturing precision of a modern jet engine was a multi-decade challenge. Overcoming this hurdle was more strategically important than any single aircraft program, as a reliable, powerful domestic engine unlocks the potential for all future combat and support aircraft, finally severing the last major technological dependency on foreign powers. If the engine was the J-11D's heart, its avionics suite was its brain, and it was here that the aircraft made its most revolutionary leap. The centerpiece of this technological transformation was its active electronically scanned array, AESA radar. This system represented a generational shift in capability over the mechanically scanned pulse Doppler radar of the J-11B and, crucially, the passive electronically scanned array, PESA radar of the Russian Su-35. The advantages of AESA technology are profound. It offers a significantly greater detection range, estimated to be an 80% increase over the J-11B's radar. Its thousands of solid-state, transmit, receive modules provide much higher resolution for targeting and identification. It is vastly more resistant to electronic jamming, and its ability to rapidly change frequencies and power levels gives it a low probability of intercept, allowing the J-11D to search for targets with a much lower risk of revealing its own position. The distinctive upwardly canted radome was a clever piece of engineering, likely designed to accommodate a larger and more powerful AESA antenna array within the confines of the flanker's nose cone, maximizing sensor performance while also subtly reducing the frontal RCS. This advanced radar was integrated into a comprehensive sensor and avionics architecture. The cockpit was a fully modern glass design, dominated by large, color multifunction displays. The aircraft was equipped with an improved IRST system for passive detection and a new, fully integrated electronic warfare suite for self-protection. There were even credible reports that the J-11D was slated to integrate a distributed aperture system, DAS, a cutting-edge network of infrared sensors providing the pilot with a 360-degree spherical view around the aircraft, a technology otherwise found only on fifth-generation fighters like the American F-35 and the Chinese J-20. This fire hose of sensor data was managed by advanced mission computers and shared across the battle space via high-bandwidth data links, allowing the J-11D to share its tactical picture with other aircraft, ships, and airborne early warning and control (AEW&C) platforms, like the KJ-500. This capability signaled a firm embrace of a U.S.-style, network-centric approach to warfare, where the fighter is not just an isolated platform, but a lethal, interconnected sensor-shooter node. The J-11D's avionics suite, particularly its AESA radar, marked a pivotal moment where Chinese technology demonstrably leapfrogged its Russian counterpart in a critical domain. While Russia's Su-35 possessed a powerful PISA radar, China's ability to develop and field a mature AESA system signaled a reversal of the traditional technology flow. Fueled by a robust domestic electronics and semiconductor industry, China was no longer just catching up. In the vital field of combat avionics, it was beginning to lead. To complement its advanced sensors, the J-11D was designed to carry a more lethal and flexible weapons load than any of its predecessors. A key structural modification was the addition of a new pylon under each wing, increasing the total number of external hardpoints from 10 on the J-11B to 12. This expanded its missile-carrying capacity, allowing it to bring more ordnance to a fight and enhancing its operational flexibility. The venerable Gryazov-Shipunov GSH-31 30mm cannon, a standard feature of the flanker family, was retained for close-in engagements. The most significant upgrade, however, was the integration of China's newest generation of air-to-air missiles. For within-visual range combat, this included the PL-10, a highly agile imaging infrared-guided missile with a high off-bore sight capability, allowing it to engage targets far off the aircraft's nose. For beyond visual range engagements, the J-11D was armed with the formidable PL-15, a long-range missile guided by its own AESA seeker, whose performance has been a source of considerable concern for Western air forces. Some reports also suggested compatibility with an even longer-ranged weapon, potentially designated the PL-17 or PL-21, designed specifically to hunt high-value assets like tankers and AEW&C aircraft from extreme distances. While conceived primarily as an air superiority fighter, the J-11D also retained the multi-role capabilities pioneered by the J-11B. It could be armed with a variety of air-to-surface munitions, including precision-guided bombs like the LS-6, anti-radiation missiles for suppressing enemy air defenses, and potent anti-ship cruise missiles such as the supersonic YJ-12. The integration of the PL-15 missile, in particular, was more than a simple weapon upgrade. It was the capstone of a new combat philosophy. The combination of the J-11D's long-range AESA radar, its secure data links, and a very long-range missile like the PL-15 created a synergistic system of systems. This enables new tactics where the J-11D could receive targeting data from an off-board sensor, such as a stealthy J-20 flying ahead or a distant KJ-500, and launch a PL-15 from well beyond the enemy's detection range without ever turning on its own radar. This doctrinal capability to function as a silent, long-range sniper transforms the aircraft into a critical node in an anti-access area denial A2AD network, posing a far greater strategic threat than its kinematic performance alone would suggest. In the global arena of advanced fourth-generation fighters, the J-11D was designed to compete with the very best. Its most direct rival was its Russian cousin, the Sukhoi Su-35S. A hypothetical duel between these two superflankers would represent a classic contest of brains versus brawn. The J-11D would hold a decisive advantage in sensor technology with its AESA radar, offering greater range, stealth, and jamming resistance compared to the Su-35's PISA system. The Chinese jet's lighter, composite-rich airframe and use of radar-absorbent materials would also give it a lower radar signature. The Su-35, however, would likely dominate in a close-in, within-visual range engagement. Its combination of more powerful AL-41F-1S engines and three-dimensional thrust vectoring control nozzles grants it a level of super-maneuverability that the J-11D, lacking TVC, could not match. The American conceptual equivalent to the J-11D is the Boeing F-15EX Eagle B-2. Both are heavily upgraded legacy airframes, but they embody different philosophies. The F-15EX is an unapologetic missile truck designed to leverage its massive payload capacity of up to 22 air-to-air missiles and its immensely powerful AN/APG-82 AESA radar to achieve air dominance through overwhelming firepower. The J-11D, by contrast, represents a more balanced approach, blending the flanker's inherent agility and long range with modern sensor fusion and a greater emphasis on signature reduction. A European counterpart is the Eurofighter Typhoon. Like the J-11D, the Typhoon makes extensive use of composite materials for a lightweight and agile airframe. The Typhoon is renowned for its exceptional kinematic performance, particularly its acceleration and sustained turn rates at high altitudes and supersonic speeds. Equipped with its own advanced Captor-E AESA radar and the Meteor long-range air-to-air missile, it is a formidable air superiority platform. In a hypothetical matchup, the larger J-11D would likely possess greater internal fuel capacity and combat range, but it might struggle to match the raw agility and high-energy performance of the Delta Canard Typhoon in a dogfight. Despite its impressive technological credentials, the Shenyang J-11D never entered serial production. Its disappearance was not due to technical failure, but rather to strategic success elsewhere. The primary factor behind the J-11D's cancellation was the unexpectedly rapid maturation of the Chengdu J-20 Mighty Dragon, China's first fifth-generation stealth fighter. By the mid-2010s, the PLAF leadership was faced with a critical resource allocation decision. Should it invest heavily in mass-producing a state-of-the-art 4.5-generation fighter, or should it commit its resources to fielding a true fifth-generation platform that represented a generational leap in capability? The cost-benefit analysis was stark. The J-11D, with its advanced composite airframe, AESA radar, and sophisticated avionics, was a complex and expensive aircraft. Reports suggested its unit cost was only slightly lower than that of the J-20. From a strategic standpoint, the stealth, sensor fusion, and network-centric design of the J-20 offered a qualitative advantage that even the most advanced flanker derivative could not hope to match. The PLAF also found a more pragmatic and cost-effective solution for its existing fourth-generation fleet. Instead of building entirely new J-11Ds, it initiated the J-11BG upgrade program. This initiative involved taking the large fleet of relatively young J-11B airframes and retrofitting them with the key technologies pioneered by the J-11D project, most notably its AESA radar, upgraded avionics, and the ability to fire the PL-10 and PL-15 missiles. This approach provided a massive capability boost to hundreds of existing fighters for a fraction of the cost of new-build aircraft. Furthermore, the dedicated multi-role strike mission was being more than adequately filled by another Shenyang product, the two-seat J-16, a flanker derivative that was entering production on a large scale. The J-11D, as a single-seat air superiority specialist, found its niche squeezed from the high end by the J-20 and from the multi-role side by the J-16. The decision to cancel the program, therefore, demonstrates a remarkable level of strategic discipline and resource management maturity. Rather than falling prey to the sunk cost fallacy or pursuing a prestigious but ultimately redundant program, the PLAF made a ruthless, data-driven choice to prioritize the future, J-20, while pragmatically optimizing the present, J-11BG. This is the behavior of a first-rate military planning organization that has a clear vision for its future force structure. Ultimately, the Shenyang J-11D program should not be viewed as a failure. On the contrary, it was a resounding success as a technology demonstrator, a strategic bridge that carried China's aerospace industry from the era of reverse engineering to the threshold of fifth-generation capabilities. The ghost of the J-11D lives on, its technological DNA woven into the fabric of China's modern air combat fleet. Its advanced AESA radar, its integrated avionics architecture, and its next-generation weapons compatibility form the core of the formidable J-11BG, an upgraded fighter that now constitutes the backbone of the PLAF's 4.5-generation air superiority force. The J-11BG is, in essence, the J-11D's brain transplanted into the body of a J-11B. Furthermore, the design and technologies perfected for the J-11D served as the direct basis for the new J-15B, a carrier-borne fighter equipped with catapult launch capabilities, AESA radar, and WS-10 engines, making it arguably the most capable carrier-based flanker variant in the world. The story of the J-11D is the story of China's military-industrial complex in miniature. A rapid, sometimes ruthless, and ultimately successful climb up the technology ladder. It is a testament to the idea that in the grand strategy of nations, sometimes the most influential aircraft are the ones that never fly in formation. The J-11D's tale is not simply one of engineering milestones or aborted production runs. It is a window into the mindset of a nation redefining its place in the global order, a laboratory in which China tested not only avionics and composites, but also the doctrine, the industrial policy, and the intellectual confidence required to pursue great power status. To grasp the significance of this aircraft, one must examine not only the technical lineage, but also the broader ecosystem that birthed it, the rivalries it illuminated, and the lessons it imprinted upon the PLAF's evolving concept of operations. The first and perhaps most important lesson concerns technological sovereignty. For decades, China's defense industry was defined by dependency, first upon Soviet advisors in the 1950s, later upon clandestine reverse engineering of Western and Russian systems, and perpetually upon foreign suppliers for critical components like engines. The J-11D symbolized the end of this adolescence. By 2015, when its prototype appeared, China had demonstrated the ability to develop an indigenous radar competitive with Western systems, to mass-produce an engine family robust enough to equip multiple frontline types, and to integrate complex software architectures without relying on Russian code. In this sense, the J-11D was less an aircraft than a declaration. China could stand on its own feet in the most unforgiving arena of technological competition. The second lesson lies in doctrine. The original Su-27s imported in the 1990s were purebred air superiority machines, optimized for visual range dogfights and brute force aerial dominance. The J-11D, however, reflected a doctrinal evolution that paralleled that of the United States from the late Cold War onward. Its AESA radar, networked data links, and long-range missiles implied a shift toward distributed lethality, beyond visual range ambushes, and cooperative engagement tactics. In essence, the PLAF was acknowledging that the age of the knife fight in the sky was giving way to the age of silent hunters, linked by invisible networks. The J-11D's very existence marked the point at which the PLAF embraced the digital battlespace as its natural habitat. A third lesson involves industrial philosophy. Russia's aerospace culture, steeped in a tradition of brilliant aerodynamics and brute force solutions, produced masterpieces like the Su-35, but struggled to innovate in avionics and software. Europe's defense industry produced exquisite systems like the Typhoon, but was paralyzed by multinational politics and cost overruns. The United States pioneered stealth and network-centric warfare, but faced spiraling costs and procurement dysfunctions. China studied them all, borrowed liberally, and then crafted its own hybrid path. The J-11D is emblematic of this pragmatism. It was never intended to be the perfect aircraft. It was intended to be a stepping stone, a crucible in which composite fabrication, radar miniaturization, mission computer integration, and engine refinement could be tested under operationally realistic conditions. By discarding it once the lessons were learned, China demonstrated an unusual willingness to sacrifice prestige for progress, a discipline many Western programs lack. The cancellation of the J-11D also sheds light on China's shifting self-confidence. In earlier decades, Beijing clung tightly to every prototype, milking each program for production numbers to prove industrial capacity. By contrast, the J-11D was quietly shelved once it had served its purpose. This reflects a mature confidence, a recognition that resources should flow toward the systems of the future rather than be wasted sustaining evolutionary dead ends. Such maturity is not universal. The U.S. Air Force, for example, has continued to purchase upgraded F-15s and F-16s decades after their design, driven by institutional inertia, congressional politics, and industrial lobbying. Russia continues to produce Su-30 and Su-35 fighters, not only because they are excellent aircraft, but also because the fifth-generation Su-57 has stumbled. By contrast, China cut off the J-11D precisely because the J-20 was succeeding. In that sense, the J-11D is a monument not to failure, but to institutional confidence. The doctrinal ripple effects of the J-11D are profound. By equipping the PLAF's J-11BG fleet with AESA radars and PL-15 missiles, China has transformed hundreds of legacy airframes into credible long-range hunters. In wartime, this means that an adversary cannot assume only the stealthy J-20 poses a beyond visual range threat. Even a decades-old flanker derivative may be capable of launching a missile from 150 kilometers away with data-linked mid-course guidance. This saturation of the battle space with long-range shooters fundamentally alters the calculus for the U.S. and its allies. No longer can they rely on superior sensors and missiles to dominate the opening stages of a fight. Instead, they face a numerically superior force equipped with broadly comparable technology. In this way, the J-11D's legacy magnifies far beyond its two prototypes. It has reshaped the balance of power across the Western Pacific. There is also a geopolitical dimension. Russia's resentment over the J-11B and J-11D programs reflects a deeper truth. The apprentice has surpassed the master. The Su-35s sold to China in the mid-2010s were in part a Russian attempt to reassert relevance. Yet the PLAF acquired only 24, more to study their AL-41 engines and Irbis E radar than to fill operational needs. By contrast, the lessons of the J-11D made clear that China no longer needed Russia's avionics expertise. If anything, Russia today is the one studying Chinese systems, as evidenced by reports of Russian interest in the PL-15's seeker technology. The J-11D thus marks the pivot point at which Sino-Russian defense relations shifted from patron-client to wary equals, and in some domains, even to subtle Chinese superiority. From an industrial policy standpoint, the J-11D illustrates how China leverages limited-run demonstrators as strategic investments. In Western terms, it resembles the YF-22 and YF-23 prototypes of the U.S. Advanced Tactical Fighter Competition, or even the F-16XL and F-15 active test beds. But whereas Western prototypes often fade into museum pieces, the J-11D's technologies were immediately cascaded into mass upgrades and spin-off designs. This reflects the Chinese doctrine of cross-pollination. No program exists in isolation, and every experiment is mined for maximum systemic gain. In the case of the J-11D, its AESA radar became standard across the flanker line. Its composites informed the J-20's refinements, and its avionics architecture provided a foundation for the J-15B. In effect, two prototypes fertilized an entire generation of aircraft. The symbolism of the J-11D also deserves attention. To Western analysts, it may appear obscure, a footnote in Jane's catalogs. To the PLAF, however, it symbolized the culmination of 2 decades of effort to escape dependency. The very act of fielding a credible AESA radar and a domestic engine in a flanker airframe was a rite of passage, a ritual affirmation that China had joined the club of true aerospace powers. That the aircraft never entered production is beside the point. Its existence marked a psychological threshold crossed. In Beijing's strategic imagination, the J-11D was the exclamation point at the end of the sentence. We no longer need you. The broader lesson for military strategists worldwide is sobering. Aircraft like the J-11D demonstrate that China's rise is not a matter of copying, but of leapfrogging. By skipping intermediate stages and harvesting only what is useful, Beijing avoids many of the pitfalls that ensnared other powers. Where the U.S. allowed the F-35 program to balloon into a trillion-dollar leviathan, China distributed its bets across multiple programs, discarding some, like the J-11D, once their lessons were absorbed, accelerating others, like the J-20, once their promise was clear, and sustaining workhorse types, like the J-16, to cover the interim. This portfolio approach minimizes risk and maximizes technological harvest, a strategy that Western bureaucracies, bound by political commitments and sunk costs, struggle to emulate. If there is a cautionary note, it lies in the limits of evolutionary airframes. The flanker, for all its brilliance, remains a design conceived in the 1970s. Its radar cross-section is inherently large, its airframe lacks internal weapons bays, and its kinematics are constrained by legacy aerodynamics. The J-11D showed how far these limits could be stretched, but also that they could not be transcended. In the end, the J-20 represented the only true path forward. The J-11D's cancellation was thus not a betrayal of the flanker, but an acknowledgement that every bloodline reaches its terminus. The torch was passed. Today, as J-20s enter service in growing numbers and the carrier-based J-35 looms on the horizon, the J-11D may seem like an anachronism. Yet its ghost lingers in every AESA-equipped flanker, every PL-15 slung beneath a J-16's wing, every WS-10 engine roaring over the East China Sea. The aircraft itself may be consigned to the boneyard, but its spirit is airborne in squadrons across China. It proved that sometimes the most important victories are invisible, not the squadrons filled, but the lessons learned, not the aircraft deployed, but the capabilities unlocked. The J-11D was never meant to fight. It was meant to teach, and in that mission, it succeeded beyond measure.